This is very, how I'd say, uh, close group. So I think they are coming from Steve Kotler's talk. Um, well, I know in the schedule we have that talking about the FlowInLife app, but I want today to talk more about why I built the FlowInLife app in the first place. So I'm gonna start with a very simple video. That video has 1 minute of describing what is the problems that we all have, and then about 3 minutes of talking about the comparison between human intelligence and artificial intelligence, and how is this going to help us solve that problem. Then we will end up in another minute talking about how this solution that we can get. So let's get into that now.
Time is the most precious asset in the universe. Once lost, it is gone forever. Yet we drift through life on autopilot, spinning in circles and wasting priceless moments. We spend years in college chasing a dream job that promises money or status, only to bounce from job to job, searching for purpose, or simply something that fits. But here's the thing, when our natural wiring and the world around us are misaligned, we feel it. It's like our inner gears are grinding, pushing against forces we can't quite name. In that storm, we try to calm ourselves, seeking moments of stillness. We binge media, hoping for quick relief or a fleeting laugh. And when that's not enough, we seek therapists, one after another, longing for someone who truly understands. When the pain becomes too much, we turn to medication, hoping for a flash of clarity. But these are band-aids or painkillers, not cures. They don't teach us how to realign our inner world with the outer one and heal the root cause. To get to the root of the problem, we need to understand, what is intelligence? Intelligence is an agent's ability to set goals, achieve them, and adapt as things around us change. But wait, what exactly do we mean by agent? An agent is anyone or anything that has agency, the ability to make choices and take action. Let's compare the two intelligent agents that present nowadays, human and artificial intelligence, or AI. AI has two basic parts, software, which is the code, and hardware, the processors that run that code. Humans, we've got the same setup. Our brain is the hardware, and our way of thinking is the software. AI hardware is made of transistors. A transistor is a simple on-off switch, like flipping a light, but it flips incredibly fast. Back in the 1950s, one transistor was about the size of a light bulb. Now, over 200 billion of them can fit on a chip smaller than your fingernail, and each one can switch up to 2 billion times per second. Now let's zoom in the human brain. If we zoom in the brain 1,000 times, you'll see about 85 billion neurons. Zoom in another 1,000 times, and you'll notice tiny protrusions on those neurons called spines. Altogether, the brain has roughly 200 trillion of these spines, and they're about the same size as those modern transistors. But here's the thing. It's not just about the count or the size. It's about the design. Spines aren't simple switches. They're complex. Zoom further in, and you'll see that each spine holds over 200 receptors. You can think of them like the old dials on a radio, analog tuners. If each of those 200 receptors had just 10 different settings, one spine could hold more than 1 followed by 200 zeros possible combinations. That's not just more than the number of stars in the universe. It's more than the number of atoms in the universe. And remember, the human brain has about 200 trillion of them. This is what gives the human brain its incredible adaptability. But it comes at a cost. Neurons are slow, can only fire up to about 200 times per second. Here's another key difference. We design transistors. We know exactly how they work. But the brain? It's of unknown design. We have to discover it. Which brings us to the software. AI runs on deliberately engineered code. and it's constantly being updated. Think about your phone or laptop. How often do you get a version update? Every few months, right? And what we get is just the final version. Behind the scenes, hundreds of versions are tested, improved, or tossed out. Only the best makes it into our hands. Even the knowledge behind this software, like computer science, evolves year after year. Now, let's look at human software, the way we think. We drift through life, shaped by school, parenting, work, and culture, without us even realizing it. So here's the big question. When was the last time we got a version update? Do we even track our version history? Even the knowledge that shape our thinking, culture, religion, psychology, education, only change once every few decades, or never. So here's the core issue. Human mental software, it's stagnant, slow to evolve, and that's a big deal because of how human brain has so many unique configurations. This problem hits us every single day. Every time we schedule a meeting, decide when to work, or even decide when to go shopping, we're not just organizing time. We're making a deep, intelligent decisions. We might be setting the wrong goals. We might be misunderstanding our own abilities. So when life shifts, and it always does, we get caught off guard. We're misaligned. We're unprepared. We struggle to adapt. That's why we need to build our mental software on purpose. Not through guesswork, but through data.
Okay, so I hope that video was insightful enough for you guys. And I want to tell you why I discussed this topic, why I compared human intelligence and artificial intelligence. Because I studied as a neuroscientist the human brain inside out, like literally. So when I talked up in the video, that's a AI generated photo of a spine, but this is a spine that I took by myself. This is a photo of that spine. So we also discovered that in another paper that even neurons and the spines, they have identity. So we can have this kind of one neuron can get identity of one memory, like the red one here, and the blue one has another identity. And then they interact together with like the yellow one. So I did study this from deep down. And then when I discovered that there is an identity for every single neuron, so I was wondering how this happens on the whole human brain. So I went to study the flow state, which is being in the zone, which is, Stephen Kotler was talking about it in the previous talk. So, and I did discover that the whole brain, when you are in the team flow, when there is a team falling in the flow, the brain has a higher power compared to if you just disrupt that flow state or disrupt the team. And surprisingly, I disrupted the team by a very simple thing, by just putting a board between two participants. And that was enough to shut down the team flow and decrease the power. But the most striking thing here is not only about these neural correlates, is that when I was trying to analyze these data, I found an issue that everyone data is very different from one another. And we need to do something called normalization over and over again. So we got funding from NASA to know how can we figure out what is these fingerprints of their neural data. So this is that was the paper that published this year, that the neural data for every single person is different from another person. So you have that person in yellow is different from that one in green. And the one in red in the middle, if they are close to each other, then they will fall more on team flow than the one that's farther away. And these are the real data that looks like, see, each blob of these is a new person. And if you zoom in, you will find his own data clustered based on his state. So And while I was doing this, life happened, and I went through mental health issue. I went to the U.S. mental health system, and I discovered that there's something interesting. Every time I go, I will answer a questionnaire called the PHQ-9, and then that questionnaire that has 9 questions, although here the copyright in 1999, which is 25-year old, in reality is not. In reality, these questions came from a very old paper that is 280 questions, and that was in 1918. That is before World War II. So that's how old and ancient is that. And interestingly, I'm not the only one who's discovering this. There is a paper that's saying that for depression, there is a 342,000 almost versions of depression. But the mental health system just treats them as just one. And that's because we don't get a neural fingerprint for each one. And this is why I wanted to create the FlowInLife, is to create that fingerprint. So I was in the spine, moved to the whole brain for EEG, and now I wanted to go from the lab to reality. This is actually the actual reason I started late. And that is why each time we try to get a solution for our mental health problem, it doesn't really work, and we feel that grinding because our fingerprints is not aligning with what's happening outside. So the FlowInLife app, I have a roundtable C. If you're interested, come and see the demo. It's at 3:30 in the second floor. So the idea is the app tracks your behavior. It has a discussion with you every now and then, so you can try to know your fingerprint. And I want to just reiterate that AI learn by iterations. That's how AI is developed. And every day we live is a new iteration, and we need to get the chance to refine our own code, create our own new version each time, and make more deeper, intelligent decisions. Thank you all. I have one question before I leave here. Do you think that the video was generated by AI or not? Okay, let me have another question, just show of hand. It was all generated by AI. Who thinks that this video was insightful? Okay, well, thank you very much.